Welcome to this recording. I'm pleased to demonstrate IBM SPSS Modeler for you today. IBM SPSS Modeler, or just Modeler for short, is a powerful predictive analytics workbench, and I think you will be excited about what you see. I'd like to point out that depending on your role, you should be looking for different things as we get into the tool. If you will be one of the lucky ones to actually use Modeler to build predictive models, I hope you see the value of its easy-to-use interface and powerful algorithms. Most members of a police organization will be consumers of Modeler's predictive output. I encourage you to look for how Modeler can deliver results and solve problems. Keep in mind that Modeler will integrate with your current systems, so the predictive results are displayed in the same way you currently view key information, be that spatially on a map, on a dashboard with graphs and charts, or on a web page, whatever method you currently use. Of course, if you would like to start from scratch, we can fashion a complete solution for you, from data collection to data storage and management, to predictive analytics and on to deployment in any form. We only have time today for one quick example, so let's begin. Let me demonstrate the point-and-click nature of Modeler so you can get a feel for how it works. Virtually anything we do in Modeler can be accessed via the nodes at the bottom, the shortcut icons, or the menus across the top. Now down below we have different nodes that are organized by various palettes. To put a node on your canvas, you simply drag and drop. There are many types of nodes you can add to your canvas, and you connect these nodes with your mouse and create a workflow. It's really that easy. You can highlight and delete, highlight and edit different nodes to specify how you want either your data to be set up, connected, altered, modeled, any of the different algorithms or settings that Modeler offers to you. For now, I'm going to delete this node that I've added to the canvas and talk a little bit about Modeler's adherence to the CRISP-DM methodology. CRISP stands for Cross-Industry Standard Process for Data Mining. The pane on the lower right contains folders to store pieces of your project and guide you through a project using this industry standard. Keeping to the spirit of CRISP-DM, let's start with business understanding and look at the problem for our demonstration. In this scenario, several of our precincts experience gang problems. Recently, a gang crime task force was created with the goal to reduce gang-related crimes. In order to track, investigate, and prevent gang-related crimes, we need to correctly classify crimes as such. Often, it is only through difficult investigative work that such a connection can be confirmed. And only after a crime is confirmed to be gang-related does the important work of the task force begin. We are going to use predictive analytics to assist with this identification process. In particular, we are going to build a model that will correctly classify a case as gang-related or not, based on complex patterns and connections in the historical data that the department already has, but is not utilizing to its full capability. Having this classification allows the task force to be involved earlier and also frees up the investigators to focus on higher priority items. Thus, public safety is increased and the department becomes more efficient. The next step in the CRISP-DM methodology is data understanding. Our goal is to build or train a model on historical case files of gang and non-gang crimes. Let's first pull in our historical profile records. To add a data source to the canvas, we choose one of the options under Sources in the tabs at the bottom of Modeler. You can see there are many different options. When we talk of predictive policing, often it boils down to being able to make those critical connections and find those hidden patterns. The unfortunate reality of most police departments today is that the data needed to connect all the dots is not yet consolidated into one neat and tidy database. Modeler helps solve this problem by easily allowing you to import data from a variety of sources. Here you see an option for the IBM SPSS Enterprise Analytic Repository. Also a database connection that supports DB2, Oracle, SQL Server, to name a few. You can import flat files such as CSV text and others. Of course, SPSS statistics files are supported. Excel and many more are also supported. Here, we select a database connection for our suspect profile data. Editing this node allows us to configure the connection. We select the data source, which in this case is our gang crime profiles, and we select a table. We can hit preview to see the connection worked successfully. Here we see that this data set contains an ID, information on the suspects, whether they are a parolee, whether they have a previous arrest and how many they have, whether they have a conviction and how many they have, and whether they are known or unknown or non-gang members. That looks good. In this scenario, we also need to connect our arrest records. These are stored in an Excel file. We can drag the Excel file to the canvas, edit the details, select our arrest reports, and preview. This dataset contains information from the arrest records such as victim age, victim gender, weapons, victims, and an injury column specifying the scale or type of injury. This looks to have imported correctly, so we close it as well. And move on to the data preparation phase of our project. Typically, this phase can take up to 80% of your time and resources. To make this as painless as possible, Modeler comes equipped with time-saving data preparation nodes found under Record Ops, Field Ops, and Graphs. Many of these options or nodes accomplish in a couple clicks what would take hours of coding otherwise. The Record Ops generally add or delete records, while Field Ops operate on fields or variables. Note the Auto Data Prep node. This node automatically executes standard prep work needed on fields before running predictive analytics. Graph options allow you to visualize and explore the patterns and connections in your data. For the purposes of our simple demo, we will need to join the suspect profile data with the crime data, and we accomplish this via a merge node. I will use my mouse to connect the disparate data sources, edit the connection, link on the key field, which is ID, and that's all we need to execute our inner join. The next step in the data prep phase is to add a type node. A type node defines the settings of each data field in preparation for model building. This node allows us to easily check and change the measurement level of our data. After we read in the values, we can see a few simple statistics that will help with this determination. Missing values are called out, and although we won't cover it today, Modeler is equipped to handle missing data. The role is critical, as it tells Modeler which fields to use for what purpose when building the model. Here we will change the ID field to Record ID, and we will change the gang field to our target, as that is what we want to classify. Preparing our data for modeling is really as easy as pointing and clicking. You can see that we are building our project with nodes and connections. The result is a logical, visual flow to our project. This is called a stream, and when we save this, it will have an str file extension. These files can be shared with others just like any computer file. We are now ready to build our model. Before we do so, many analysts like to look at an overview of the data to get a solid understanding of the raw materials we have to work with. The Data Audit node is a popular option for doing this. Clicking the play button allows me to see the output of this node. Here you can see each of the different variables, their measurement level, and a few simple statistics. The graphical histograms are often the most useful. Opening up the gang graph, we can see that over half of the records in our data set are known gang-related suspects. Of the other half, about half of that is not gang and about half is unknown. Keep in mind that gang is colored light blue, non-gang red, and unknown dark blue. With those colors in mind, we can look through the other variables and see some that might have a strong correlation to being good predictors of gang. The first one that jumps out to me is victim age. You can see as the age is young, there's a lot of light blue, signifying a high correlation to gang-related crimes. Simple correlations like this are easy for most people to spot and are often common knowledge among the department. What might be interesting is how victim age interacts with other variables in our data set. Perhaps with high victim age and a low previous arrest count, we have a high correlation of non-gang crimes. Interactions like these, and adding other variables into the mix, with 3- and 4-way interactions, are often very difficult for the human mind to comprehend. This is one of the ways and areas where data mining and predictive analytics adds a lot of value in finding these hidden patterns and making these connections. We now turn to the modeling phase of our project. The model will be trained to determine if a case is gang-related, non-gang-related, or unknown. An unknown classification means there was not enough evidence for the model to make a call. and these cases will go through the traditional channel of investigation. There are many state-of-the-art data mining and predictive analytical algorithms at your disposal in Modeler. One popular feature with novice and expert alike are the auto nodes: auto classifier, auto numeric, and auto cluster. Given that we are trying to predict which one of only 3 possible values a case will have, we will use the auto classifier, and we add this node to the palette and connect it to the type node. As we do so, you can see that gang appears as the label of this node. The auto classifier knows that gang is a target because we specified that in the type node. As we edit the node, you can see that there are many settings for fine-tuning our model and getting the most predictive power that we can by playing with the features. It does come populated, however, with smart defaults, and often these defaults are not changed. Under the Expert tab, we can see the collection of algorithms that the auto classifier node is going to use. Here you can remove methods, alter settings, and so on. For now, we will simply keep the defaults and run the auto classifier. Modeler is now going through each of these algorithms, building a model, and testing those models based on the criteria we selected or that were in the defaults. The models that perform well will be chosen. A key feature to point out is that more than one model is usually chosen for the final prediction. In fact, the final prediction is based on an ensemble model, which is an average of sorts of the top performing models. The ensemble model increases accuracy by averaging predictions across models while taking into account the confidence each model has in its prediction. By double-clicking on the resulting model nugget, we can see which models passed our criteria. In this case, 3 models were chosen to make the ensemble prediction: a Bayesian network, a C5 regression tree, and a neural network. This concludes the modeling phase of our project. Here I think it is important to emphasize the ease of use of Modeler in leveraging the power of predictive analytics without writing one line of code. We now graduate on to the evaluation phase. Let's look briefly at the results of each model to see the connections and patterns discovered by these algorithms used to predict gang-related crimes. Starting with the Bayesian network, we can see a network diagram off to the left with our key input fields listed together and connections between them. Off to the right, we have a conditional probability table. In this case, victim age is separated into buckets or categories represented by the columns, and the rows represent the different classifications of gang, no gang, or unknown. And in the table, we see the probabilities generated by the Bayesian network. One piece of information that looks to be useful here is the location of weapons in the network. Weapons is right in the middle of our network, with connections to pretty much every other variable of importance. Weapons tends to interact with all these different inputs to help us give a good prediction of gang. Clicking on weapons, we can see its conditional probability table off to the right. Scrolling through and looking for high values, we can see that this particular high value of 0.88 occurs when there is no weapon and when the victim age is rather large. In that case, there's a high probability that crime was gang-related. Perhaps it's common knowledge, perhaps not. Again, this is one of the hidden patterns that data mining can help you discover. Moving on to the classification tree. The classification tree is a great way to view in a graphical format the logic that goes into data mining and predictive analytics. Let me open up a few windows here to navigate the tree. So we start with all of our records, most of them gang, and the others split between non-gang and unknown. And the most important variable in the classification tree is conviction. If conviction is at 0, then we almost always bucket them as unknown. However, when conviction is greater than 0, 1 or higher, we can expand the tree to see how the other variables will play out. Previous arrest, in this case, turns out to be the second most important variable. When previous arrests are 3 or lower, those crimes have a high probability of being gang-related. However, when previous arrests are greater than 3, generally, they're not gang-related. Perhaps most gang members are only arrested several times before they are incarcerated for long periods of time, which would mean that they rarely get more than several arrests. In any case, we can drill down into the previous arrests that were 3 or lower, and we can see if the victim age is young, the probability of that being a gang-related crime increases even more. You can see that almost 90% of the cases in this category were gang-related. Drilling down further, we can see that weapons further distinguishes this victims over 28 category. If a gun was involved in the crime, then it's not always gang-related. However, if there was no weapon or other weapons with a high victim age, it tends to have a little more probability to be gang-related. It's subtle interactions and patterns and connections like this that can only be found with predictive analytics. As we wrap up this project, let's talk about deployment. This model is now a valuable asset to the Gang Crime Task Force. Although the algorithms are complicated, the result is easy to understand and can be seen via a table node. We can right-click on the table node and hit Run to see the output of the model. As we scroll to the right, the important fields are the last two. Here we have the prediction that the model gave as to whether a crime was unknown, gang-related, or non-gang-related. The final column is the confidence that was behind that prediction. What we like to see is an agreement between the reality and the prediction. And as we saw before, this model does a very good job. So again, we have a prediction and a confidence score for that prediction for each case. As we get new cases in our system, we simply feed them into our model, and the model gives us a prediction and a confidence score, which we can then use to make quick and more accurate decisions, leading to increased public safety and saving valuable department resources. This analytical asset we have created is not a static asset. As we feed the system new data, we periodically check challenger models and can spot significant trends as they are emerging. There are many applications of predictive analytics for today's police departments. Today we looked at one example. Hopefully this demonstration has given you a feel for how Modeler works and how its results can be fed into your existing systems and add significant value. IBM SPSS Modeler's goal is to help you transform your department from a state of watch and react to one of predict and act. Thank you for watching.